Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Rich Burke.
William, thank you for the introduction, and welcome to today's Tech to Tech session. Today's session is going to focus on underside wipe process and more specifically around the relationship between the price, cost of materials, and more particularly the cost of the cleaning agent that one might use and the total process costs. More specifically, what we'll look at is the three different possible choices one would use when it comes to underside wipe: dry wipe, wet wipe with IPA, and we'll look at wet wipe with an engineered cleaning agent. And the real question is, can we afford to ignore looking at these questions? In terms of the printing process, this session will not go into let's say, all the parameters and the optimization of a printer. Those topics have been covered in the past through our Tech to Tech series. So by all means, if you haven't attended those, by all means, go to the website, go to our Tech to Tech, and you can see a lot of information there. But in terms of the printer itself, just stepping back, the primary purpose of the printer is to print or place an exact amount of material in a precise location. Obviously, the objective is to have a good quality print, and we need to try to do everything we can to avoid the bad and the ugly prints, or they're causing rework and repair. So to focus in this session, it really will be around the selection of materials that are used for the underside wipe process, and again, most specifically around the cleaning agents that one might choose. And these are choices. First, one might look to do a wet wipe process. In that case, the cleaning agent cost is zero. Obviously, there's no cleaning agent to be used. When we talk about wet wiping, we can utilize either IPA or engineered cleaning agents, and you can see the relative cost differences between the two choices. 20 gallon on average is around $20 a gallon for IPA, as compared to an engineered cleaning agent in the neighborhood of $25 to $55 per gallon. So clearly the cost of the material when it comes to an engineered cleaning agent is much higher, but in the end it actually can save thousands, and we'll walk through kind of why that is, and hopefully help you make more informed decisions. So when we look at the economics of printing in terms of the underside wipe topic, we can see that there are two categories of cost drivers. There are those that are visual or obvious, and this includes the selection of the stencil, whether it be a coated or non-coated stencil, the selection of the cleaning agent, the selection of a paper for the roller, and then there are a group of costs that are hidden. And the first one we might look at would be the cost impact of the evaporation rate of the cleaning agent one uses, or the saturation rates, or the saturation requirements for a given material. What is the cost impact of a misprint? What is the cost impact of the number of prints that we can run between wipe cycles? The cost of a defect in terms of yield, and then ultimately cost per print really is what we're trying to drive towards. So, when we step back and look at all of these costs, the reality is oftentimes we see that the hidden costs contribute significantly to the overall total cost of that process. And in fact, in the neighborhood of 85% of the costs in total come from this hidden or non-clear cost components. So really, it's important to focus on these hidden costs when we're really trying to look at the total cost of operating the process. First, let's look at, so we'll step back now and look at each of these. So we'll look at a dry wipe, we'll look at a wet wipe with IPA, and a wet wipe with an engineered cleaning agent. So first, what we want to look at is just the pros and the cons of this selection. So first, obviously, would be a pro might be no cleaning agent costs. So from a cost of that process, that would be a pro. Cons would be the limited ability to remove a solder paste. There would be no ability to solubilize that solder paste. And when it comes to fine pitch apertures, very often one would not want to or be able to run a dry wipe process. When we look at the imaging here, what we see is if we were to take a stencil out after it's been dry wiped, and we were to look at that and take a photo, we can actually very often see solder paste remaining inside of the apertures. The bottom series of pictures actually does a great job of showing you the impact of smearing of the flux residue that's in that solder paste as after a dry wipe process. This is illustrated by using a UV tracer in the solder paste and then looking at that under a black light. So it makes it very obvious to one that there is limitations in terms of let's say, the cleaning ability of that dry wipe process. I would say if you're running 5 prints or less between the dry wipe cycle, you really ought to look at the benefit that would come along with an engineered cleaning agent. Not only would it likely be cost effective, but it would also likely improve the quality of the prints or the yield. Next, when we look at wet wipe with IPA, in terms of pros, we have low cost of the material, and also obviously IPA is readily available. So I would say those are 2 pros. In terms of cons, the first would be the limited ability of the IPA to solubilize the material. It tends to streak because it's not solubilizing that material very well. Also, it dries fast. And so because it's drying fast, that can add cost because we need to use more material to saturate that paper and compensate for the quick drying of an IPA. Also, it can dry out the apertures, causing poor print release. And then lastly, but not insignificant, is it is a flammable material, and therefore, from a health safety standpoint, something that we may want to consider. And in terms of the printer manufacturers, none of them actually would recommend the use of IPA for that reason. In terms of the images that you see here, in the top you see some vials with solder paste in IPA, and what you're really looking at is, again, the example of the inability of the IPA to solubilize many of these solder pastes, as compared to utilization of an engineered cleaning agent, where we can see those same solder pastes are very well solubilized. And again, that's because the material is designed for the application. And similar to dry wipe, if you're wiping after every 5 prints or less, from a cost perspective, going to an engineered cleaning agent would very likely save you money. So in terms of wet wipe with IPA, in terms of some imaging, just take a look at this if you can. This is showing you using, again, a UV tracer and looking at both coated and non-coated stencils. And so what we have here is, first looking at this is a dry wipe cycle. This is a wet wipe cycle with IPA, this series of pictures. And this series of pictures here is a wet wipe with an engineered solvent. And because the UV tracer is in the solder paste, we're able to clearly see the streaking that comes from a inability to remove that flux residue or the solder paste residue. So again, in a dry wipe application, we would have, with fine apertures, we'd likely have solder paste remaining in the aperture, but we're also seeing streaking on the stencil. We also see that here with IPA. Again, it's not able to solubilize a lot of the flux residue, so we actually can detect that. Now, if you were just to hold that stencil up by the naked eye, it may appear clean to you, but this really does have a good ability to show you what's really going on. And you can see quite a difference when we go to an engineered cleaning agent. And again, this would be true of both coated, so these are 2 nano-coated stencils here, and non-coated stencils. So again, talking of the engineered cleaning agent wet wipe process, this really is one of the most misunderstood products that's utilized on the manufacturing floor. And I think it's really because we just don't focus much on the underside wipe process as a whole. We can utilize both water and solvent-based products, and I think the most important thing there is they are designed specifically for the application. In doing so, they can really deliver cost benefits to your operation. It can come from reduction of solder defects, so yield improvement. It can come from increasing the number of prints between wipe cycles. You might be running a 1, 2, or 3 today if you're running an IPA process or you're running a dry wipe. And we would very often be able to increase that to 7, 10, 13, or more prints between cycles when we're using an engineered cleaning agent. We can increase the number of prints before having to remove that stencil and do an offline stencil cleaning operation. Again, can deliver cost savings. And we can see an increase in transfer efficiency, again, yield improvement. And again, this is true with or without the use of nano-coated stencils. So circling back now, let's look at some costs for a minute. So again, the question that we started out with, can we afford to ignore these hidden costs? So let's look at the true impact of what we're talking about. So in this I have two cost models for us. The first one is looking at in comparison between a process was running IPA versus an engineered cleaning agent for that same underside wipe process. So in the first customer example, that customer was running a underside wipe process after every 2 prints, and we're extending that to every 5 prints with an engineered cleaning agent. In this case, it's 8 printers running 2 shifts. And what we see here is the annual cost savings of just over $29,000 when they make that change from an IPA wet wipe to a wet wipe process with an engineering cleaning agent. So again, we know that the cleaning agent itself, engineering cleaning agent, that is more expensive per gallon or liter, but we can clearly see when we factor in everything that it actually does save money. And you can see specifically what's driving that. So we have a cleaning agent cost of IPA annually around $21,000, and as compared to the engineered solvent annual cost consumption $5,000, so a $16,000 savings. Paper, the consumption on the IPA wet wipe process at $24,000 in this example, as compared to $11,000 for the engineer using the engineering cleaning agent. So $13,000 of savings. And more specifically, what's driving this is, the cost per wipe for a printer is the same, irrespective of the material. And obviously, the cost per liter of the engineering solvent or engineering cleaning agent is higher than that of IPA. But going back to the evaporation rate is much higher in IPA, and that then means more material has to be applied to the paper to yield the result we're looking for. So you can see over 2 times the amount of material, and that equates to an increase of cost per wipe when we go to an IPA process as compared to an engineered cleaning agent. So this, coupled with the fact that you're wiping after every 2nd print as compared to after every 5 print, is what's really driving these cost differences from a solvent to an engineering cleaning chemistry or on the paper side, right? So again, cost per liter per gallon is not the only thing we should be looking at. In fact, it doesn't have as big of an impact as the other parameters would have. So let's look at a dry wipe for a second. So in a dry wipe example, in this case, customer was wiping after every print. The engineering cleaning agent extended that to every 5 prints. In this example, 7 printers running 2 shifts. And again, we actually do see a significant cost savings, just over $21,000. And again, when we look at what's driving this, obviously, when we go to a dry wipe process, no cleaning agent is used, so there is no cleaning agent cost. And when we look at the cleaning agent cost of the engineering cleaning agent, it is actually costing that customer $4,000, right? So it's adding cost. But the cost savings in this example is really driven from the paper and the consumption of paper, and that's really because the wipe is actually happening after every print as compared to every 5 prints. So that is a significant driver in what's affecting this cost model. So again, think in this case, I guess the question might be, if we're able to deliver same or improved quality or yield, and save money, the question really is, why would one ever want to run a dry wipe process? So anyways, we'll leave you with that question. So to summarize, hidden costs are highly impactful when it comes to the overall process costs. And these hidden costs are often overlooked. We often focus solely on the cost of the cleaning agent that we're using. Engineered cleaning agents for stencil cleaning provide the highest performance, but also, again, lowest total cost of operation. And I would leave you with this. I think the most important thing is to really think of it in terms of cost per print, not cost per gallon or liter. So to end, have a few questions that are often asked, and the first one being, well, why is IPA still used so often in underside wipe process? That's a great question, and I would just say I think it's really perception. I think overall the industry perceives IPA to be a low-cost solution. It perceives the use of IPA and underside wipe to be effective, and I think when you step back and really look at the total cost of that equation, it clearly is not, in most cases, a cost-effective solution. Its inability to solubilize these materials means that it truly is not an effective cleaning material for the application. And then I would say, just the last thing to keep in mind is, again, from a health and safety standpoint, the printer manufacturers don't recommend it. So I would just say it's a matter of perception and maybe education. I think we all have to do a better job of educating the industry in terms of the pros and the cons of utilization of IPA for this application. Next question: Can the same engineering cleaning agent be used in the offline stencil cleaner? In many cases, it can. It really will come down to the particular cleaning agent and the equipment set that you would have for your offline stencil cleaner. So, we can help you with that. So, by all means, reach out and we'll help you with that selection. The last question: which is better, water or solvent-based cleaning agents? I would just say it's like every process. It depends. In many cases, a water-based cleaning agent will be adequate and sufficient and do everything we want it to do. In other cases, a solvent blend would have value and benefits. It really just comes down to the process, optimization of that process, and again, that's something that we certainly can help you with. So with that, I will say thank you for your time. I really hope you found this informative and got something out of it. And with that, Will, I'll turn it back over to you.
Thanks, Rich. Thank you guys for watching this Tech-to-Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.